Now I want to share with you another amazing project called ecological forecasting. Let me introduce you to the team. There's Jeff Simeon, Greg Frasco, and Shashank Karthikeyan from Boston University SAIL team who helped develop applications. And Dongchen Zhang, our PhD student at Boston University, and our professor Michael Dietz, who does everything ecological forecasting, and myself. So we provide ecological forecasting services like the Pecan platform for doing ecological forecasting. It's an open source software. And we build a RStudio Jupyter Notebook container image to run our ecological forecasting code with all of our R dependencies built in and other tools that are Pecan related. We have Helm charts for easy deployment of Pecan on Red Hat OpenShift and NERC. So the Pecan ecological forecast model run front end is here, and we'll dive into that in just a moment. We have deployed the custom metrics autoscaler operator in NERC because we want to be able to scale model runs. It's running algorithms. We want that to scale depending on the number of messages coming into the message broker. So we've deployed a scaled object here that's configured to integrate with RabbitMQ. RabbitMQ is the trigger on queue length. So we can scale up to 5 pods here whenever multiple messages come into the SIPnet R136 queue, it will increase the number of pods in our deployment. So to show you that here, and to show you scalability, we have a deployment that's currently running no pods. It's auto-scaled to 0, and we're going to bump that up. So let's try this out. We're going to do some forecasting. So we go to models and we choose SIPnet R136. I'll choose Ameriflex as the site group. I'll zoom in here and you can see that we have some areas where we can do forecasting. I'll select this wilderness here and click next. And then I'll choose temperate coniferous data and edit the Pecan XML because we don't want to just run one forecast. We're going to run 50. So we change the ensemble size to 50 and save this and then continue. And this is going to start running some forecasting. Let me see if I can move some things around so that you can see the pod auto scaling. And we have a monitor. And if we refresh this, it shows 50 messages, see? And then here the pod is auto-scaling now. It's auto-scaled to 1. And if we refresh over here, we have 1 consumer. And now it's auto-scaling to 4. And it shows 4 consumers on the left here. So this is working. This is running our model. And this is showing its updates over here. So live scaling of ecological forecasting is happening right now. It's pretty exciting. Running. And finished. So that was fast. So you can review the data here in the user interface. Now let's continue on We can also run jobs in NERC OpenShift, like one-time jobs here, because with ecological forecasting, we have to download a whole bunch of data, and we run a one-time job in OpenShift for that. The which one was it? Pecan unconstrained forecast. So that's an example of one-time jobs. We can also run cron jobs to run every day, for example, to download the latest forecast so that it's ready to run. And that's what we're doing here with the HarvMet download EFI script. So one-time jobs and cron jobs are really powerful. They're in OpenShift. We also use Red Hat OpenShift Data Science. So if you want to start using Red Hat OpenShift Data Science, you can do what we did, which is find the right Jupyter Notebook base image for what you want to do. For us, we found the right image in OpenDataHub-IO-contrib, Workbench images, and GitHub. This has our studio images that we built our image off of to include all of our pecan dependencies. So build your dependencies right into your notebook image. See how we created a container image that is from this Jupyter Notebook, our studio image, and then we go and apply all of our pecan dependencies to that, install the packages. And then we deploy an image stream to NERC. That's the next step. The image stream looks like this. You specify in the notebook image URL, image name, image description, and the image itself. And then team members can go and create their own roads workbenches inside of NERC roads. So here is my image here. So to give you a sample of what it's like running in roads, here is our RStudio, and I can pull up a script. You can get a persistent volume to put whatever you want in your little workbench here. And I put pecan in there, and I put a forecast example, and in pecan scripts, HarvMet download. This is some forecasting that downloads forecast data, and I can run this script either line by line in here by creating a console editor. I already have one open, so I'll close that one. You can run lines with Shift Enter and then check on what the NC dir value is, for example. So that's really fun to do. We can also run the script directly like this to start downloading that important ecological forecasting data. So that's it. I hope that helps you understand how to use the powerful scalable features of NERC OpenShift, as well as the powerful data science features of Red Hat OpenShift Data Science, from a smart village platform to ecological forecasting.